Hi everyone! In this video, we will identify functions. Identify whether each relation is a function. We are given 5 relations as a set of ordered pairs, and we need to decide if they are functions. The definition of a function is that every x has exactly one y. So in looking through our list of ordered pairs, the first thing we want to do is see if we have a duplicate x value. If it gives us the same y value, then it will be a function. If it has a different one, then it will show us that the x value does not have exactly one y value. So I'm going to go through and circle all of the x values and just look to see if any of them are duplicated. The x value of -5 doesn't show up again, so it only has one y value. The 7 also doesn't show up again in the list, and the 2 and the +5 again only show up once. So this one we can say is a function because each of those x values has exactly one y value. Now with the second one, again, let's circle all of the x values, and we can see right at the first that we have a duplicate of -3. The -9 and 0 are not duplicates, so let's look at the -3s. The -3 shows us that we have a y value of 8 and a y value of 3. So this violates the definition of a function where every x value has to have exactly one y value because the x value of -3 has two y values, 8 and 3. So we will list this as not a function. Our third example, let's go ahead and we will circle all of the x values again just to identify them and see if we have any duplicates. I see that we have a -7 at the first ordered pair and at the last ordered pair. And then we can look at the y values. The first -7 has a +10 and the last -7 has a 3. So this again violates the rule of every x having exactly one y value because the -7 has two different y values, 10 and 3. So we will define this one as not a function as well. Our fourth one, let's go ahead and circle all of our x values yet again and see if we have any duplicates. We have 7, 3, -3, and -1, which means none of them are repeated, and that means that every single one of those x values will only have one y value since we don't see it more than once. So this one will be defined as a function. And the last one, again, just circling the x's so that we can identify where they all are. And again, we have a duplicate here with the 2's, 2 and 2. And then we look at the y's, we can see that this x value has a y value, 2 goes to the 6, and the second one, this 2 has a 3. So this x value of 2 has two y values of 6 and 3. So it violates the definition, meaning that this is also defined as not a function. Had we had the list of ordered pairs in which the 2 was duplicated and it was duplicated to the exact same y value, in other words, if this y value were not a 3, if it were a 6, then we could say that it is a function because that 2 maps to the 6 in both cases. In ours, though, it did not map to a 6, it mapped to a 3, so it would be considered not a function. But just in case you see a duplicate, make sure that it is a different y value so that it violates or does not violate the definition. We've identified all of the functions here for each of these relations, and now we're all done.